Today, we are basically tearing down and rebuilding one of the most fundamental assumptions in international trade. We're taking a really deep dive into spatial location theory, specifically looking at this brilliant paper by Hong Wang and Chao-Chung Mai on the tariff jumping argument. If you think you know exactly how a firm is going to respond to an international tariff, well, get ready to have your microeconomic models pushed to the absolute next level. Let's get right into it. All right, let me throw a question at you right off the bat. Do tariffs absolutely always force companies to relocate across a border? Think about traditional foreign direct investment theory for a second. The standard assumption, the one printed in basically every undergrad textbook, is that when a foreign country slaps a massive tariff on your exports, your firm will eventually jump that tariff wall. You'll pack up your domestic plant, relocate to the foreign territory, and just produce locally to escape the tax. I mean, it seems like basic, undeniable common sense, right?
Well, get ready, because here is the intellectual bomb we're dropping today. Higher tariffs actually do not always make firms relocate. In fact, depending on the firm's production scales, a higher tariff can surprisingly anchor a firm to its home country. It sounds like a total paradox, I know, but it's driven by pure mathematical logic. Sometimes, the heavier the tax, the stronger the geographic pull to stay exactly where you are. So here is our game plan for the explainer. We'll quickly cover the tariff jumping paradox, break down cost versus location effects, and build our spatial location model. Then we'll dive into how returns to scale act as our mathematical engine, visualize the shift graphically, and finally look at some real-world policy applications.
Okay, part one, cost versus location effects. This is where Huang and Mai's research really starts to shift the paradigm. So traditional literature focuses heavily on the cost-induced effect. You know the drill. Tariffs increase your export costs, so you jump the tariff wall, build a factory abroad, and save money. Makes sense. But what that traditional theory totally misses is that foreign investment is intrinsically a physical change in location. And that brings us to the location-induced effect. I want you to picture a massive physical tug of war. On one end of the rope, you've got the cost of lugging your raw materials from their source. On the other end, you have the cost of shipping your final, finished products to the foreign market. Your factory is the flag in the middle of that rope, literally getting yanked by whichever transport cost happens to be heavier.
Let's move on to the spatial location model and actually map this market out to see how that tug of war plays out geographically. Imagine a simple, straight horizontal line. Think of this as our entire market space. Way over on the far left, we have point I. That's our domestic input source. It's where the raw materials come out of the ground. Right smack in the middle is point B, the border between domestic and foreign. And all the way on the far right is point J, the foreign output market where consumers actually buy your product. Now our firm, a monopoly in this scenario, has to figure out exactly where to drop its plant along this line. Do they hug the raw materials at point I? Do they get closer to the buyers at point J? Or do they land somewhere in between? So, what exactly controls who wins this tug of war? To figure that out, we have to look at the mathematical engine driving this whole thing, returns to scale.
Let's make sure we've got this definition locked down. Returns to scale is basically a mathematical rule that shows how the relationship between your transportable inputs, we'll call those M for materials, and your final outputs, let's call that Q, how that relationship changes when you tweak your production size. Why does this matter so much? Well, think about it. When a foreign country suddenly jacks up a tariff, your immediate reaction as a business is going to be to produce less, right? You shrink production. But as you shrink, the ratio of the inputs you need versus the output you make starts to warp. If you cut your final output in half, do your raw material needs drop by exactly half? More than half? Less? That ratio is literally everything.
And this ratio perfectly maps out exactly how a firm reacts geographically. Let's look at 3 scenarios. First up, decreasing returns to scale. Here, when the tariff forces you to cut output, your input usage actually falls faster than your output. So the raw materials become relatively lighter to transport compared to the finished goods. The tug of war shifts, the foreign market pulls harder, and boom, the tariff causes you to relocate abroad. Now, scenario 2, increasing returns to scale. Output falls, but input usage doesn't drop nearly as fast. Suddenly, raw materials make up a much heavier chunk of your transport burden. The input source pulls the rope harder, and you are anchored right there in your home country. Finally, scenario 3, constant returns. The ratio just doesn't change. It's perfectly balanced, so the effect on location is completely neutral. Okay, so the math dictates the geography. Now it's time to get our hands dirty. Let's visualize this shift with a step-by-step graphical tutorial. Let's put our professor hats on and reverse engineer these corner solutions. If we focus on the upper part of this model, you'll see a negatively sloped T-curve. The vertical axis is our tariff rate, T, and the horizontal is our raw material input, M. It perfectly shows that first rule we talked about. As the tariff T climbs higher, your input usage, M, drops. You produce less, so naturally you buy fewer raw materials. Simple enough, right? Keep that in the back of your mind as we slide down to the lower section. Now, down in the lower section, this is where the real magic happens. See that concave curve? That represents our decreasing returns to scale. And that straight diagonal line cutting through, starting from 0, that's our boundary. The schedule where transport costs for inputs and outputs are perfectly matched. Under free trade, 0 tariffs, we are sitting comfortably at equilibrium E0. Notice how E0 is tucked below that boundary line. That means raw materials are heavier to move, so the firm stays home to save on shipping. But wait, what happens when a tariff hits? Input M drops. We slide left along that concave curve over to equilibrium E1. And look at that. E1 actually crosses above the boundary line. Just like that, shipping the final output becomes heavier. The foreign market wins the tug of war, mathematically forcing the firm to pack its bags and move across the border. It is a brilliant visual of the location-induced effect in action.
All right, we've conquered the chalkboard theory. Let's talk about some real-world policy applications.
Because economics isn't just Greek letters, it's what actually happens in the real world. Hong and Mai highlight this incredibly fascinating parallel. Let's flip the script for a second. Imagine a domestic country importing raw materials from abroad to build a final product. The spatial logic still holds up perfectly. If the foreign government slaps an export tax on its raw materials, which, fun fact, is exactly what Indonesia did with their plywood industry, it acts as the exact inverse trigger to an import tariff, but it creates the exact same spatial tug of war. Depending on the economies of scale in making plywood, that export tax can force a location-induced foreign direct investment. The firm literally moves its plant to Indonesia, all because that shifting ratio of inputs to outputs moved the physical center of gravity for their transport costs.
Which brings us to a final, pretty massive question. If spatial logic and returns to scale are secretly dictating where firms move, how does this location-induced effect reshape the global tariff wars we're seeing in today's crazy, complex supply chains? Think about it. When a country raises tariffs today, policymakers usually assume they're just, punishing foreign competitors or forcing them to relocate. But as we've just proved, if those industries are operating under increasing returns to scale, those exact same tariffs might literally be cementing those factories into their foreign home soils permanently. It is a wild paradox, and it completely proves why we absolutely have to integrate spatial location theory into how we understand global trade. I really hope this explainer flipped your perspective on the whole tariff jumping assumption. Keep questioning those standard textbook models, and we'll see you in the next explainer.